welcome to H.E.L headquarters in Hemel Hempstead. I am Dr. Mario Torres Rodrigo, the applications leader here at H.E.L. And today we are in our applications last demo lab. Today we are going to have an overview on our PolyBLOCK system. Our PolyBLOCK system is H.E.L's solution to increase the high throughput of chemical reactions. Depending on the system, we're going to have as default up to 8 individual reactors that will allow to test different characteristics and different parameters in real time, increasing the capacity of our research in order to test all these individual variables. But the one that I have with us today is our PolyBLOCK 4 that we can have here that can hold 4 individual reactors of up to half a liter. When I mean that we can control individually the reactors, I don't mean only the temperature or the agitation. Instead, we can individually control every one of the parameters that we are testing for our reaction. The way that we can achieve this is through our proprietary software, WinISO, that is developed here in headquarters by our software team. And let's have a bit of an overview first on how the hardware looks like, and then we can have also a look into the software. So as I said, let's start with the hardware itself. And the first thing that we notice is the PolyBLOCK itself. The PolyBLOCK contains a mantle that is going to control the temperature of all the individual zones in which the reactors sit. But also we have other ways to control temperature. We can see here on the side, we have this double connection. This connection allows us to communicate our PolyBLOCK with circulators in order to cool down our reactions faster. In this case, we will have an oil or water, depending on the physical reactions and the physical parameters that we require for our reaction, in which the oil or the water is going to go in through this connection, and is going to go inside of the PolyBLOCK, coming out of this way, helping us to regulate the temperature. Let's start having a bit of an overview of different glass reactors for atmospheric pressure. So we have, for example, this one is a half a liter reaction. In this case, we have it connected with direct agitation. As we can see here, this connection would be attached to a motor that will be able to control the agitation inside of the reactor. Direct agitation is appropriate for when we have very slow agitation, as low as, for example, 50 RPMs, or when we have very viscous liquids. Other things that we can see in our reactors is that our lids are designed by us. So let's move this out of the way so we can see it closer to the camera. So here we are. This is how the lids look like, and they have different holes that can be blanked out. So for example, we can do it here for this demonstration in case that we are not being used. But thanks to these orifices that we have in the lid, we can control and we can add different probes. So for example, we can have, as we see here, a temperature probe, but we can have dissolved oxygen, we have pH probes, all depending on the needs of the customer. So let's put this one back in and let's have a look at the smaller sizes. So for example, we have this one here. This is a 150 ml reactor. The first thing that might attract our attention is how are we able to ensure that there is an optimal heat exchange between our reactor and our PolyBLOCK if there is such a big difference in sizes. All of this is achieved thanks to our adapters that, as you can see, completely engulf our reactors, and they are in contact with the metal inside of the of the reactor, ensuring that there is this ideal heat exchange. So then they are as simple as just feed them like this. We have other sizes as well. We have smaller vials, such as, for example, here is a 20 milliliter vial, and it has a thermal probe. And again, we can provide adapters that very snugly fit our reactors. What is very important to highlight about PolyBLOCK is that we have different options in terms of agitation. As I mentioned on this one had a direct agitation, but in this case, we have a magnetic agitation here. We can see when we connect a magnet that is inside of the PolyBLOCK, and then it'll ensure that there is a complete agitation inside of the vessel. But also, one of the biggest fears that we can have with magnetic agitation is that in certain cases, there might be a case of decoupling. You know, the typical sound when you have a fluid that is just moving around inside of the reactor and it makes that clinkety clanky sound. However, to avoid that, WinISO is able to test the coupling between our agitation inside of the vessel and our PolyBLOCK, and it is able to ensure and reconnect the magnetism in a way that we are going to avoid this decoupling. We have other sizes as well. We can, for example, have this kind of adapter that will allow us to have a number of 2 milliliter vessels. In this case, the agitation obviously cannot be direct, but having small fleas, we can ensure that there is agitation inside of the bottles. And we can go even as small as this. And we have even some adapters that would allow us to have 3 individual connections like this on one of our vessels. And this is in terms of glass reactors, so atmospheric pressure reactors, but we can also offer high pressure. And in this case, we can go to reactors that would look like this. So this is a Willingham reactor, and again, the lid is designed in a way that we can have different probes depending on the needs of the customer. We offer different sizes as well. So for example, this would be a 300 milliliter reactor that could go up to 200 bar of pressure. And here we have some more examples of things that we can add to the lid. We have, again, this is a thermocouple to measure temperature, but we can have, for example, samplers. We can have gas samplers, we can have liquid samplers, but we can also add other lines so we can feed or retrieve liquid or gases from the reactor. If we open the reactor, we could see how they look inside. And I think that's basically a big summary of how the hardware itself works. So I think we can have a bit of a look into the software. So now that we have had an overview of the hardware, let's look into the software. The software that is going to control a PolyBLOCK is WinISO, the proprietary software that we develop in-house here at H.E.L, and it's designed to monitor and control everything that is going in the system. So when we open it, we would see an image like we have in front of us. That is what we call the mimic screen, in which we can see a graphical representation of the system. We can see, for example, that in this one we have 4 individual reactors, and in 2 of them there's going to be magnetic agitation, as we can see here and here, but also we can see that we are going to be controlling all the parameters such as the pressure and the temperature and the temperature inside of the reactor. So one of the things that we can do with WinISO very easily is that we can control individually each one of the parameters. So it would be as simple as double clicking on the parameter we want to change and we would change it. But also what we are having at the moment is just an overview of the whole system. We can also see how each one of the individual reactors are behaving. So for example, we can just double click on this reactor farm and it will zoom in and it will give us a description of our reactor. So one of the things we can do, as I mentioned, is we can double click and then we can change the agitation, for example, of our reactor. And we would see here that in the mimic screen, the reactor is starting to be agitated, and we would see exactly the same in our hardware. So let's pause this. We can do exactly the same with the temperatures or with how much heat the heater is supplying, but this is not where WinISO's power resides. Actually, what we pride ourselves here at H.E.L is that we are very good at providing optimized solutions for customers. So what we can do is actually creating a plan. Plans are the programmed recipes that you can input into WinISO in order to optimize your process. One of the advantages that WinISO has is that you can save your plans as files. So this means that you don't need to be in the lab when you're designing your plan. You can actually be in your desk, in your office, and you have the idea for that plan. You can write it and then you can save it and then export it and bring it to the computer attached to your PolyBLOCK, for example, on a USB drive, connect it, and then you can add it to WinISO. So let's have a bit of a look on how you would design a plan. So it is a very straightforward, it's a very powerful method as well, because we can add as many steps and as many branches as we want. So we would simply go here to plan, and then we have new. And then this is a very simple system, but your WinISO would have as many variables here as the probes and attachments that you have added to your PolyBLOCK would have. So let's assume that we have a chemical reaction that is going to have a number of steps. And the first step that we have is that we want to maintain the temperature in our reagent A at a certain temperature, and we want to make sure that it's thoroughly stirred. So let's have a first step that we can call heat up. And then we would have the heater on, and we can set the temperature to 40 degrees. And to make sure that it's very agitated and the temperature and the concentration is thorough, let's put it as going to be 400 RPM. And then we can add logical conditions for our step to progress to the next one. So in this case, we can ensure that our step is going to happen for 10 minutes. And then we can insert a new step. And in this case, we have added our second reagent into the mix, and then we are going to increase the temperature to, for example, 60 degrees. And we're going to increase the agitation to a certain value. I'm going to show you that with WinISO, there is a theoretical limit at which you can run your agitation, for example, and if you go over that, it will give you a warning message. So let's assume that we want to have our reactor being agitated at 2000 RPM. That is over the limit. So actually, WinISO will return a message saying that the maximum is 1500. So let's change that to 1500. And then we want to make the reaction to happen for another 10 minutes. Let's call this mix. We're going to have another step that is going to be a stir out, in which the temperature is going to be a bit lower. Let's assume it's going to be 50 degrees, and it's going to still maintaining a very high agitation for another 5 minutes. And then we're going to have a final step that is going to be a cool down. And we're going to take the temperature down to 25 degrees. And the agitation, we're going to decrease it to 250 RPM. But as I mentioned before, we can have also branches. So let's assume that our process, when we are mixing the reagents, it can be an exothermic reaction that is going to produce a lot of heat, and that heat can be dangerous. So we can add another step after mix here. That is going to be a cool system that can happen. We can take the temperature down to 50 degrees once again, and we can maintain a very high agitation to ensure that this cooling down happens very quickly. And we can change the logical condition here and say, okay, so when the temperature in our reactor is less than 50 degrees, then we can move our reaction to mix once again. And then what we would see is that here we have heat up is going to proceed at 40 degrees. After 10 minutes, it will go into this mix at 60 degrees and very high agitation. And what we would add here is a condition once again, so it's add temp. And in this case, we would tell the system, okay, if the temperature inside of our reactor is higher than 65 degrees, then instead of, you will go to cool system. And when this is completed, then we will move to the step out system. So we can see that we can create loops in the process. Also, one of the things that is core to H.E.L is that we are originally a process safety company, and as such, safety is spread throughout all our system and all our hardware. So we can add extra conditions and extra safety measures to our process. So let's have a quick look on how we do this. So here on this safety button, then we would have this window. And what we can do is add different steps that can give us extra safety measures. So for example, let's assume that the critical step in our reaction is going to be mixed, as we said before. So in this case, we can tell the system, okay, if the temperature inside of the reactor goes over 65 degrees, in that case, please give me a warning. And when it gives you a warning, a message will appear on the screen saying, warning, these conditions have been met. And also you would receive a sounding warning that would alert you that something is going awry. And we can also add extra steps. So for example, we have talked about warnings, but also we can add a shutdown in case things go wrong. So in this case, just imagine that the temperature is increasing even further. And in that case, we have a problem because the situation can be even further dangerous after 75 degrees. So in this case, instead of a warning, please give me a shutdown state. And then we can go here and we have different shutdown states. So in this case, we can tell the system, okay, if this is the case, I want the heater immediately off and I want the agitation to be as high as possible. And if we had a circulator attached, what we would do is enhancing the cooling down from the circulator until the situation is okay. So this will be a complete shutdown of the system. So now that we have our plan, then what we can do, we can save the plan. So we can save it here and we can call it, for example, test 3. And it'll create a PLM file that is going to contain our plan. Then we can just save it. And then we can just press run and run the plan. When we press run, we'll receive this window in which it'll allow us to rename. For example, we can call this test plan, and it will ask us what kind of format we want to save. So .dat, that is the format that IQ, the software that WinISO uses to analyze data, is provided by H.E.L, but also we can save it in a more universal format such as CSV. So now we can check what happens when we run a program. So we just press OK here, and we will have this multi-window here. So we're going to see different steps in different windows. So let's have a look into them, what they mean. So what we have here in the top left-hand side is the mimic screen. So we can see that our reactor is working and things are happening inside. So we can see that the magnetic agitation is on and it's just mixing our reactor. So right at the bottom of this screen, what we have is the live measurements of what is going on inside of our reaction. So we can see that we have the agitation and we have the reaction temperature. But we are not married to this. We can change our graph and we can add as many graphs as we want in there. So let's see what we can do with this. So if we press this button here, what it will give us is this window that contains all the parameters that are being measured as we speak. So we can just decide, okay, we want, obviously on the x-axis, we want our time, but what if we don't really want to only have the reactant temperature? We also want to have the requested power to the mantle. So in that case, we can add another condition here, and we can decide what color to plot it. It's going to be purple, and then we can increase the lines with, for example, 2, 3. And automatically the graph will change and it will give us whatever we're interested in plotting. We can also, on the same window, we can change, for example, the axes. So we can see that the temperatures are too broad, so we are not being able to see as much as we would like to see. So in that case, we can just increase the left axis. Instead of being 100, we can put it up to 70 degrees. And same with the other axis. So we can just press OK, and the graph will be reformatted. We can add more graphs, and then we can decide how we want to lay them out. So let's change here, for example, and add here on the X. We want this one on the right hand side, red with a line of 4, and we can have the stereo power, for example, as well on the left axis in dark blue with a line width of 4. And then we can decide how we want to plot them. So we want, for example, 2 of them side by side, have one here again, so we can just come here, boom. We can have just one here like we see here. More things that we can see on WinISO when it's running. So this middle top window here represents what is happening on the reactor from a numerical perspective, so we can keep control of the different parameters. Next to it, what we have is the plan itself. So we have the 5 steps that we created, and they are going to be color coded. So in red is the future steps that haven't happened yet, in green is the current step that is running, and in blue we will have the past ones that have been completed already. And then on the bottom right hand side of the window, what we have is the current step of the plan. One thing that we can do is that we understand that sometimes when we're inputting our plans, we make human error, and what WinISO allows you to do is modify the parameters as we go. So let's assume that we made a mistake, and instead of wanting our temperature in the reactor to be 40, maybe it's a bit too high to start with, so we can just reduce it with double click to 30, and then WinISO will give us a message telling us, you are making a change, are you sure you want to do this? And then we would press OK, and in our graph it'll be represented as this green line. This green line is a comment, so if we just click on it, it will tell us that there has been a changing the temperature of the heater to 30 degrees. Another thing we can do is skipping steps. So let's imagine that our reactor has reached the temperature that we want. It's already around 30 degrees, which is what we wanted. So in that case, what we can do is telling the software, okay, let's end the step and move to the next one. So we just press here, and then when ISO again to confirm that you're sure that you want to do it, it will give you this warning, and then we say yes, okay, and then we'll move to the next step. And what we see is that we have now this red line here. This red line indicates that the step has finished and we are progressing to the next one. And we can appreciate here what I mentioned before, that now that we have finished the step, now it's become blue, and then we have green because it's the next one. And I think that's pretty much everything that we can show from a software perspective. And I think that that's pretty much it from a demo perspective of a PolyBLOCK system from H.E.L. So if you have any questions, if you have any comments, please reach out to our salesperson, and then we can guide you in these questions. Thank you very much.